Hello and welcome to another Algebra 1 video tutorial. In Lesson 10.9 we'll be looking at systems of inequalities. Our goal will be to graphically solve systems of linear inequalities in two variables. Big idea, the graph of the solutions to a system of linear inequalities is a region bounded by the lines. Okay, so example 1. Graph all solutions to the system x is greater than or equal to 0 and y is greater than or equal to 0. Okay, now normally previously you've learned how to graph these individually. X is greater than or equal to 0, so you'd have a vertical line through 0, and we would shade to the right of this. Okay. Now we're not going to shade yet because we have a second one we have to worry about too, so there's going to be a common shaded region. So I just draw a few arrows showing which direction I would shade. Okay, then we look at y is greater than or equal to 0, so we graph the boundary line, y equals 0, so these are both solid lines because they could equal. And we would shade it above that, like so, and we can see now where are there arrows pointing into. What's the common shaded region? Would be the first quadrant. So you would shade the first quadrant. Okay, so that would be all the solutions to the system. All right, graph the solution to the system here. 2x plus 8y is less than 16, and y is greater than negative x plus 5. Okay, the first equation is in what we call standard form, so we need to graph this boundary line, and the easiest thing is to get the x and y intercepts rather than solve it for y and get slope intercept. It's up to you. You could solve it for y and get slope intercept if you're comfortable with that. So the x-intercept, we set y to 0, so 2 times what is 16? That would be 8. So first coordinate we'd plot would be 8, 0 right here. And then for the y-intercept, we set x to 0, so we say 2 times 0 plus 8 times what is 16? Well, that would be 2. So our next point we would plot would be 0, 2. Now, it's less than 16, so we have a dashed line. So we connect these with a dashed line. And then, which direction would we shade? Well, it's less than, and it's a positive y. But let's test 0, 0. That's not on our boundary. It's not on our line, on our boundary line. So we can test 0, 0 for x and y. So 0 plus 0 is less than 16, true. So we should shade below this line. Okay, now we go into the next one. It's in slope intercept. So it has a y-intercept of 5. So we'd plot 0, 5. And a slope of negative 1. So we'd go down 1 and over 1, down 1, over 1. It is another dashed line. So we connect those 2 points with a dashed line. And now, we could test 0, 0, or y is by itself and is greater than, so we'd shade above this particular line. So where are the arrows pointing to? This common region right here is what we would shade, and then I can erase my marks, and there is my solution set right there. Okay, number 3. Graph the solutions to this system. So we have negative x plus 4y is greater than or equal to 1, and 2x plus y is less than 10. Okay, so this one is also in standard form. So we would, for the x-intercept, we'd set y to 0, so negative x equals 1. Well, divide by negative 1, so x is going to equal negative 1. So we would have an x-intercept at negative 1, 0. So we'd plot that point. Now, the next one is going to be 4 times what is 1? 1 divided by 4, so 1/4. So it's going to cross at 1/4 right here. That's hard to estimate. So if you went from here to here, that's going up 1/4 and over 1. So it has a 1/4 slope, so we could go up 1 and right 4 and put us at the point 3, 1 if we wanted to. Or we could put a point at 0 1/4. That's just a little harder to estimate. All right, it's greater than or equal to, so it's a solid line because it could equal it. Test 0, 0, because it's close, but it's not on the boundary line. 0 plus 0 is greater than or equal to 1. No, that's not true, so we'd shade the other way. So we'd shade above the line in this case. We'll draw our arrows kind of indicating. Now the next one is in standard form. 2 times what, so set y to 0 for the x-intercept. 2 times what is 10? 5, so we'd plot a point at 5, 0. That would be our x-intercept. Y-intercept is going to be 10 because 1y equals 10, so we'd have a y-intercept at 10. So we'd plot those coordinates. It's a dashed line because it's not equal to, it's just less than. And which direction would we shade? Well, 0 plus 0, if we test 0, 0, 0 plus 0 is less than 10, that's true. So we'd shade below the line, but once I can see that this is the common shaded region, so we'd go ahead and shade that and erase our arrows if you had to. You don't have to erase them on your paper. Lightly shade this with your pen. Okay, or pencil. All right, number 4. Y is less than x plus 13, and y is greater than or equal to negative 1/3 x plus 5. Now, this one, on my graph paper, I'm going to leave it as going from negative 10 to 10, so like a standard window. So I wouldn't be able to plot the y-intercept of 13. So when does, and I know this has a positive 1 slope, so I know it's going to start up here at 13 and then have a positive 1 slope, so it's going to come through here. What point does it actually show up on my graph? Well, if it's 3 units above, well, we could go down 3, left 3, so it would put us at that point right there at negative 310. And then it's a positive 1 slope. Well, you can't keep going in that direction, so go down 1, left 1. That's the same as a positive 1 slope. And it's a dashed line because it's just less than, but not equal to. And which way would we shade? Well, it's y is by itself and it's less than, so we'd shade below it. Also, 0 is less than 13, so it would shade below it because 0, 0 works. All right, the next one, it's in slope-intercept, y-intercept of 5, so plot that at 5. Slope of negative 1/3 is going to go down 1/3, so I'm going fairly quickly through these lines because that's chapter 6, stuff you learned quite a while ago. It's a solid line, we connect that. And which direction would we shade? Well, it's greater than, so we'd shade above that since y is by itself. So the common shaded region is this region here, and go ahead and turn your pencil on its side and lightly shade that, and I'll erase my pen marks. All right, now what if we're given a system and we have to describe the shaded region with a system of inequalities? So our shaded area is right here, so we need to come up with an equation for the lines first and foremost. Okay, so this line right here, it has a y-intercept of 3, so it's going to be something plus 3. What is its slope? Well, it's going to go up 1 and over 3, so it has a 1/3 slope. So it'll be y equals 1/3 x plus 3. Y equals 1/3 x plus 3. This other one is going to have a y-intercept of 2, so it's something minus 2, and it goes up 2 and over 1, so it has a slope of 2. So 2x, y equals 2x minus 2. Now all we have to do is make this a system and decide if we shade above or below that. So what's the inequality going to be? So y 1/3 x plus 3. Now this line here, and it's above it and it's solid, so it would be greater than or equal to. This other line, y 2x minus 2, what's the symbol that goes in there? Well, it's solid and it's shaded below it, right? It's below this one, above this one. So this is going to be less than or equal to in that case there. All right, number 6. Describe this shaded region with a system of inequalities. Well, let's get the boundary lines first. This line right here appears to be y equals 6. It's a horizontal line. This one appears to have a y-intercept of 8. What is its slope? Well, it appears to go down 2 and right 1, put you at that point. Down 2, right 1, that's the slope of negative 2, so negative 2x. Y equals negative 2x plus 8. All right, what is my system? Well, it's below the horizontal line and above this one, so it's going to be y is less than or equal to 6 because it's a solid line and it's below, so y is less than or equal to. This one's a dashed line and it's above, so it's going to be y is greater than negative 2x plus 8. All right, number 7, describe the shaded region with a system of inequalities. Now in this case we have a triangular region, which so that's going to be 3 equations of lines. So we need to come up with those 3 equations first. So let's do this line here, which appears to have a y-intercept of negative 7 and a slope of what? Well, it appears this is a point. It looks like it goes down 2 over 1, so it'll be negative 2x. So y equals negative 2x. That's a negative. Y equals negative 2x minus 7. This one right here appears to have a y-intercept of 5, so it's something plus 5. And a slope of what? Well, it appears this is an integer point, so it would go up 4 units over 1, so that's a slope of 4, so y equals 4x plus 5. And then our last one has a y-intercept of 8. Y-intercept of 8 and a slope of, it appears a slope of 1. It rises 1, runs 1, so it'll be y equals x plus 8 for that one. Okay, well, it's shaded below that one. So it's going to be, let me use a different color here. So it's going to be a solid line and it's below it. So y is less than or equal to x plus 8. And so that takes care of that line right there. And it's below it. Okay, and let's do the next one here. It's above this line, and it's solid, so it's going to be y is greater than or equal to 4x plus 5. And that takes care of that line right there. And then we have this last one here. And it's above this line, so it'd be y, and it's solid, so it'd be y is greater than or equal to negative 2x minus 7. So there would be the region bounded by this system of inequalities. All right, and then our last example. Mr. Luckeson's class has $265 to spend for red trim and pile fabric to make vests for a play. The red trim costs $1.25 per yard and the pile fabric costs $6 per yard. The number of yards of pile fabric they purchase cannot exceed twice the number of red trim they buy. So part A, write a system of inequalities that describes the total number of yards of red trim R and yards of pile fabric P that Mr. Luckeson's class can purchase. Okay. So our system of inequalities. So let's do one about the money. So we have less than or equal to $265 to spend. So it's going to be $1.25 for every yard of red trim plus $6 a yard for every yard of pile fabric. And up to $265, but you could spend it, so less than or equal to $265. And then the last one, the number of yards of pile fabric cannot exceed twice the number of red trim yards they could buy. So we'd say 2R, something like that. All right, part B, graph all combinations they could buy. Okay, so this first one's in standard form. We could get the x and y intercepts or the r and p intercepts. So for the r-intercept, we set p to 0, so we'd take 265 divided by 1.25. That would put you at 212. So 212, 0 would be one of the coordinates. Do the opposite. For the p-intercept, you would take 265 divided by 6, right, because you'd set r to 0. And that would get you 44 and a sixth, so 0, 44 and 1/6. And there's going to be a solid line. Connect that, and it's 0, 0 work, so you'd shade below this line. Shade below this line. And I suppose technically we would have two more equations, there's inequalities here. We'd probably say p is greater than or equal to 0 and r is greater than or equal to 0. So we'd be to the right of this. So it would put us in the first quadrant. To the right of this line and above this line. That's kind of obvious, but we could state that. Okay, and then the second equation, the y-intercept is 0. So we'd plot a point at 0, 0. And now the slope is 2. Now if we go up 2 and over 1, that's kind of hard to judge. Even if we went up 10 and over 5, that's kind of hard to judge. So let's go up 50 and over 25 and put a point at 25. 50. Okay, and that's going to be a solid line connected there. And we're going to shade below that one. We can't test 0, 0 because it's on the line, but p is by itself and it's less than, so we'd shade below here. And you can see this common region here is this triangular region that we would shade, and it would be all the solutions that they could buy. Number of yards of pile fabric and yards of red trim are going to be in this solution set of this triangle there. Okay, that wraps this up. A lot of graphing for you. So you'll have to maybe review chapter 6 on your graphing techniques and what you know about slope and y-intercepts and standard form. All right, your assignment will be 10-9, page 637, 2 to 20 evens. Thanks for watching, and we'll see you next time.